In this question, we have carbon dioxide plus water yields CH4 plus 2O2. And we're told that the reaction is endothermic. And then we're asked what will happen to the equilibrium if we change the temperature by raising or lowering the temperature. So the key thing to point out here is, first, this is a reversible reaction. Second, that the reaction is endothermic. The way I learned this is we consider for an endothermic reaction that heat is a reactant. So heat is a reactant because if you want to drive the reaction forward, you have to add heat. For an exothermic reaction, heat would be a product. So here, heat is a reactant, and in the other case, heat would be a product. So much like in the previous question on this playlist, it's easier to first determine the shift in the equilibrium and then determine the change in composition. So the temperature is raised, which means we add more heat. Well, in an endothermic reaction where heat is a reactant, making the temperature go up or adding more heat shifts the reaction to the right. So we can shift the reaction towards the products by adding more heat. So the pressure of carbon dioxide when the reaction shifts to the right will decrease the amount of carbon dioxide, will increase the amount of methane and oxygen. So this, in this case, this will go down because we raised the temperature, added more heat, shifted the reaction to the right to maintain equilibrium, which decreased the pressure of the carbon dioxide. In the second case, the temperature is lowered, which means the reaction will shift to the left in order to add more heat in. So the pressure of methane will also go down because the reaction shifts to the left to increase the amount of heat. The methane is consumed when that occurs, and the pressure will go down. So again, if it's an endothermic reaction, think of heat as a reactant. If it's an exothermic reaction, think of heat as a product, and that will help you to solve these problems.